Hi guys, this is a Mastermind Alliance tuition video on Surds. It's a GCSE video. It mainly covers the Edexcel syllabus, but it does cover the majority of other boards as well. So what is a surd? A surd is normally written in this form here. So it's inside a square root symbol. A surd will represent a number in its exact form. Now, what do I mean by that? Well, let's look at this number here. It's quite a long number, 45.658465845. If you was using or writing a sum and it included that number, it'd get pretty tiring writing that number out again and again and again. So what the smart few of us will probably do is end up rounding that. And what we would tend to get is 45.66 if we rounded it to 2 decimal places. Now, 45.66 isn't this long number here written exactly. It's not the exact same thing. It's pretty much there, but we're missing out all these numbers here. What a surd will do is it will include all these numbers here, but just write it in this shortened form. Square root 8. Now the reasons I've got these written here, you'll find out in a minute. So if you've got a scientific calculator with you, and you was to write square root 8, you would see this appear in your calculators, 2 square root 2. Now this number here is the simplified version of square root 8. And if you was then to press the SD button at that point, you would get 2.828427125. That there is what number square root 8 represents. As you can probably tell, it's a lot easier to write square root 8 than write out a number this long. Now, same with square root 32. If you've got your calculator and you write square root 32 into your calculator, you'll get 4 square root 2. If you press the SD button on the calculator, you'd get 5.656854249. And that number there is square root 32 exactly. So before we just talked about simplifying surds and how these numbers here are the simplified forms of these surds. In your exam paper, you may be asked to actually do that. Now, how do we do it? You might notice that I've written out the square numbers at the bottom of the slide. Why have I done that? When we're simplifying surds, you would need to use the lowest square number that is a factor of the number inside the surd. So if we think about 18, we've got square root 18. What square number goes into 18? I know 9 goes into 18. So what I'd then do is I'd write square root 9 times square root 2 equals square root 18. Am I done? No. But look at this number here, square root 9. I can actually find out the answer to that. I know the answer to that. The answer to that is 3. Can I square root 2? No. So I leave that as it is. So my answer is 3 square root 2. Let me look at this one now. So square root 24, the highest square number or the lowest square number that I know that goes into 24 is 4. Square root 4 times square root 6 equals square root 24. I know what the square root of 4 is. The square root of 4 is 2. Do I know what the square root of 6 is? No. So I'm just going to leave it as 2 square root 6. Now if I look at the next one, the lowest square number that goes into 12 is 4, and that would be, sorry, square root 4 times square root 3 equals square root 12. Can I square root that 4? Yes, I can. I know the square root of 4 is 2. Do I know the square root of 3? No, I don't. I'll leave it as it is. 2 square root 3 is my simplified version of square root 12. Square root 25, the lowest square number that goes into 50. Sorry, I was giving the answer away there completely. So square root of 50, the lowest number that goes into square number that goes into 50 is 25. So square root 25 times by square root 2, and that would give you the answer of square root 50. Do I know what the answer of square root 25 is? Yes, I do. The answer is 5. Do I know the answer of square root 2? No, so I'm just going to put square root 2. So all these here are simplified versions of surds. Calculations using surds. This top one here you'll probably already know, just because of the slides that we covered before. So if we look here, 9 times 2 equals square root 18, 4 times 6 equals square root 24. All you do is you multiply the numbers inside the square root bracket, square root symbol. So here our answer would be square root 18. And we know that's not the simplified form of that. To simplify that further, we'd have to find a square root that goes, a square number that goes into 18, which we covered before. And if you remember from the example on the previous page, that would be 9 times square root 2 equals square root 18. And we know that square root 9 equals 3, and we don't know square root 2, so we leave that as it is. So our answer here would be 3 square root 2. When we've got surds with a number outside the square root symbol, we deal with their numbers first. So 9 times 7 in this case would be 63, and 8 times 2 in this case would be 16. Now 16 is actually a square number, so the square root of 16 is 4. Our answer in this case would be 63 times 4, which equals, if you just figure it out, 252. Again, we've got numbers outside the square root symbol. So 4 times 3 is 12, and 5 times 3 is 15. So you got 12 square root 15. Can we square root 15? No, we can't. We leave that number as it is. 50 divided by 2 is square root 25. 25 is a square number. We square root that, and what you'd get is an answer of 5. 36 divided by 9, we would get an answer of 4. And 48 divided by 3, you get an answer of 16. 16 is a square number, so 4 times 4 equals, and your final answer would be 16. You might also be asked to use surds in Pythagoras' theorem. We all know that Pythagoras' theorem is a squared plus b squared equals c squared. What we've got here is two of our sides written in the surd form. So 18, square root of 18, let's bring this down here, plus square root of 6 is going to give us our hypotenuse, which is AB. So let's have a quick look at the question. Always read the question. Calculate the length of AB. Leave your answer in the said form. So here we've got 18 plus 6. We have to remember that these are squared. Now the funny thing about squaring a square root, all you need to do is when you're squaring a square root is take away the square root sign. So let me show you how that makes sense. Imagine we've got square root 5 and we want to square it. Now we know that 5 squared equals 25. And the square root of 25 equals 5. So look what's gone on here. All we've done is taken out this square root symbol and you're just left with 5. So what does that mean for us up here? That means that this is 18 plus 6, which equals 24. Square root 24. Now, the reason that's square root 24 is because we need to actually find our answer. That would give us 24 squared. We're going to find out what the hypotenuse is, so you square root that. Now, from what we were doing before, we know that we can simplify 24, the square root of 24. Our square numbers tell us that square root 4 times square root 6 equals square root 24, which means our answer is 2 square root 6. And that there is your final answer. Okay. Calculate the area. Give your answer in the form a plus b square root 3. Now, this comes up quite a lot in exam papers. I'll explain exactly what that is after we've done the sum. So we'll look back at that and then explain why that's important. First of all, I want to calculate the area. Now, the area of a square is length times width. So we know that we have to times this third by this. So speaking of that, I don't know why that's there, if I'm honest. Let's take this out. It's not correct. So it's that times that. Okay, so we know from expanding brackets that when you times the two together, we need to use the smiley face method. Now the smiley face method would give us the following answer. 2 times 2 is 4. 2 times third 3 would give us 2 third 3 plus 2 third 3 again plus square root of 3 times square root of 3 is the same as square root of 3 squared. So all we need to do is take the square root symbol out. That's exactly what we just covered before on the previous slide. Okay, so let's start to collate our values here. Let's probably make these the right size. We're gonna get confused. Okay, so let's start to collate our values. So here we've got a 4 and a 3. What I'm going to do is going to separate the surds out a bit so you can just see where the surds are and where the numbers are. We've got a 4 and 3 here. So 4 plus 3 is 7. So we've added that 4 and 3, so they're eliminated. Now we've got these two surds. On the previous slides, we talked about multiplying surds and we talked about dividing surds. We didn't talk about adding surds. And when you're adding surds, what we need to do is worry about the number outside the square root symbol. So here we've got 2 and 2. So 2 plus 2 is 4. The square root symbol and the 3 would stay exactly the same when you're adding them. So the answer here is 4 square root 3. That answer is in the format of that. So 7 would be A, 4 would be B, and said 3 is there as well. So rationalizing the denominator. When we're dealing with fractions, the denominator, which is the bottom number, can never ever be a surd. It can never be a square root. So what we need to do is we need to get rid of these numbers here. How do we get rid of that number? We multiply it by itself. So we would do 3 times square root 3. Which we know by now equals just 3 by itself because it's 3 squared and then square rooted. And then the top number would be 1 times square root 3. And 1 times square root 3 is just square root 3. So your answer here would just be 3 square root 3 over 3. Excuse my bent line there. What about this one? This one's a bit trickier. So we do the same thing again. We times the bottom by itself and then we times the top by that as well. So let's just get the square root sign. Let's say we've got 8 there. So there and 8 there as well. Now we'll have a square root in front of it. Move that along. And all we want to do is times them. So 8 square root 8 times 8 square root 8 equals just 8 by itself, which is what we talked about before. And then we've got 2 square root 3 times square root of 8. Okay, so from our previous slide, we talked about multiplying surds, and we know that 3 times 8 equals 24. So what would happen here is you'd get 2 square root 24. So 2 square root 24 over 8. Get my bent line back out. Still a bent line there, line there. So 2 square root 24 over 8. That is not in its simplest form still, because we can actually simplify that square root 24. How can we do that? Well, we know that if we think about our square numbers, that you can get 4 times 6 is equal to 24. So square root 4 times square root 6 equals 24. And we're not going to forget about this 2 here, because that 2 is still involved. So 2 times square root 4 times square root 6, and that would be over 8 still. Get my bent line back out. Should really use a straight line, but being a bit lazy. And we know what the square root of 2 is now. Sorry, the square root of 4, sorry. So the square root of 4 is 2. So that's 2 times 2. We don't know what the square root of 6 is, so we'll leave that as it is, over 8. So our final answer would be 4 square root 6 over 8. And that would be your final answer. And that is also everything that you would need to know about surds.